So we'll be going into what is called angular velocity. Now, the angular velocity, this is the rate of change of angular displacement with respect to time. So it's represented using the symbol omega, right, equals to what? The change in angular displacement over what? The change in t. One thing you need to know, that in circular paths, the speed is constant, right? The speed is constant. You know, speed is a scalar quantity. The angular speed is what? The speed there is what? Is constant, because speed doesn't have direction. But the angular velocity is not constant. The velocity changes with time, right? So we use it, we'll call it gamma here. Angular velocity, it changes with time, and it is the theta over the t. It is measured in rad per seconds. You know, in your normal linear velocity, it is the rate of change of displacement with time, but here now is angular displacement with respect to time. So the speed is constant, the velocity is not constant, it changes. Is that okay? As we move further, I'll explain that better. Now, the next thing we're talking about now will be angular acceleration. The angular acceleration, since the velocity changes with time, right, then the acceleration will now be the rate of change of angular velocity with respect to time. And that will give us the symbol for angular acceleration is what? Alpha. The symbol for angular velocity is what? Omega. Right? Then the symbol for displacement is what? Theta. So let's go back to this. So my alpha here now will now give me the omega over the t. That means angular velocity over what? Time. So which is seen as final velocity minus initial velocity all over time. And it's something we'll call our centripetal acceleration, which is v squared over r. As we move further, I'll explain that. Is that okay? So just like we have the laws, just like we have the laws of motion, the equation of motion, we also have the equation of what? The equation of angular motion, right? The equation of angular motion. Is that okay? So we also have the equation of angular motion, which says that what? My final angular velocity is equals to what? Initial angular velocity minus what? Angular acceleration times time. Equation 1, right? So we also have the displacement is equals to what? Initial angular velocity times time plus 1 over 2 alpha t squared, right? I will also have my final angular velocity is square is equals to initial angular velocity square plus 2 angular acceleration times what? Times theta. So this is the equation of angular what? Motion. So you need to know that, right? So I've already told you earlier that this man here, angular final, is giving us final angular as velocity, right? Then this one is giving us initial angular velocity. We have angular acceleration. We have angular displacement, and what else again? We have the time, and so on and so forth. So we'll see in our next video.